leaving it to students all the ideas. The first one case I'll discuss. You're supposed to work out all this. No. Let's begin that one. So it is going to leave circular path. It is clearly telling after leaving circular path. Let's take this one. So this is the so when it leaving circular path, what are the conditions? It will have velocity. So as usual, we'll take this as theta, length of the string. No, now what should be the path? The path I am going to show after leaving circular path. So it's going to describe a parabolic path. Then it passes. What is that green color? Path of the bob. The bob will be in that position. So you should pass through where the bob should point of suspension. Can it happen? Yes, it can happen. If you want, you can try this. In your own, no, you can try this one. So this is the V. This should be the theta, no? This is theta. This is theta. This should be the theta. Let's come for all the mathematics here. First, we need velocity here, no? So for that, what can be this distance? L sine theta. This is L. I'll have water. Meanwhile, you try this one. No, this should be equal to condition to leave circular path. There'll be tension T. What is the equation? Basic equations we write. This will be theta, no? So T plus mg sine theta equal to mv square by L. To leave circular path, at P. So tension must be 0. So then above equation will end up like this. Mg sine theta equal to mv square by L. So what is V equal to root of GL sine theta? Keep one equation in mind. What was our question? To get that you know, let me apply conservation of mechanical energy. Mu square by 2 equal to mgl 1 plus sine theta mv square by L. Try to see the conservation of mechanics between point A and P. We applied it. So this will be
mv
u
square by
square.
2, sir.
This is 2, no? In place of V square, you can write it as GL sine theta. So this should be u square is equal to 2GL, or GL I'll take outside, 2 plus 3 sine theta. I think already you are able to remember that. So instead of doing all this, better directly come for equation 2. I already told you. Please do remember. Can you recollect? Condition to leave circular path, what's be the initial velocity in terms of what is theta? Theta angle made by the string with what? With horizontal. There I took angle phi. Here I made theta. Anything. So this formula you do remember. Many numericals you can directly start from here. So there's the advantage of how in exams how to save time. These are things which you have to make observation. No, come for after this. What is the thing? I think we did we reach answer. This theta is unknown, no? Because What is the condition for theta? The theta is such that here the bob should pass through the point of suspension. So here's the bob. Bob will be here. This will be bob. It's not that. And the string will be. And finally, what when the bob will come here. Next afterwards, the bob will be like this. Length of the string will not change. Okay, so these are the very generalized, realistic things what a student must have an idea. Length of the string will decrease. No, length of string will be there. So this is the thing. Okay, now come for. We don't know theta, no? How to bring the theta into the picture. So I'll take help of the projectile motion. We have some information. What is the height it has descended when it moves from P to L sine theta? Then it will take some time. So let me solve mathematically. Minus L sine theta is equal to V cos theta t minus g t square by 2. From where this equation I brought it? When it moves from P to O, from for parabolic path PO. I'm writing equation. When it moves from P to O, what is the height it will descend? L sine theta. What is the component of velocity along y-axis? V cos theta. So S equal to ut plus half it square. So why negative sign? Because look at this displacement. When it moves from P to O, how is the displacement? Opposite to initial velocity, V cos theta. Got this, and the yg negative, opposite to initial velocity. So there's a one equation. So keep this equation 3. Then what is the range? So horizontal displacement, how much it will cover? L cos theta. So can we write equation for this? L cos theta should be equal to V sine theta into T. So replace this T here, solve for theta. Then the value of sine theta, what you'll get, you have to substitute here. So this is equation 4. So why this is brought? This is for the range, horizontal distance. L, when it moves from P to A, what is the horizontal displacement is having? L cos theta. Due to what? Due to V sine theta. Now substituting 4 in 3. L sine theta. What is V? V I should write it, no? V should be equal to root GL sine theta. T is how much? L cos theta by, I think this V will cancel out, no need of, let me have as it is. T will be L cos theta by V sine theta minus G by 2. This will be L cos theta by V sine theta whole square. Minus L sine theta VL cos square theta sine theta minus G by 2 L
Sir,
square
it will
cos
get
square
cancelled.
theta.
It is L cos square T2.
Which one? Fine, no?
Sir, we will get cancelled.
We will get cancelled, yeah. This will be G sine theta. I'm substituting the value of V square. V square is what happened? GL sine theta, sine square theta, L cos square theta. So I think L, G also get cancelled. So what all equation will end up with only theta, sine theta, cos square theta, sine theta, minus cos square theta 2 sine cube theta. Anybody value?
And theta 1 by root 3.
Sine theta.
1 by root 3, sir.
1 by root 3. Yeah? So therefore the velocity will be, if I substitute here, so the velocity, the required velocity will be u square equal to gl 2 plus root 3. Is it okay? I think based on the sine theta value, I wrote this one. Just verify one sine theta value. So this is our answer. Now similarly, what happened? I can also ask you what speed you should project so that it will pass through point of projection or somewhere at any point. So I can ask you any specific point, but the overall I think you have to bring the condition to leave circular path and also the projectile motion.